Hello guys, so today we're talking about trigonometric equation transformations. Okay, so let's move into this part. So for this kind of questions, there's a very common P3 tricks problem. Like here, tan 3x equals to 3 cot x. Okay, so most of the times we can say like you can just using the rules for tan 3x and then you can divide it into tan x plus 2x and then just using the tangent rule. Because we knew that for tangent A plus B can be considered as the tangent A plus tangent B divided by 1 minus tangent A tangent B, right? So you can just using this expand rules to just expand tangent x plus 2x. So the rules here, then we can be written as tangent x plus tangent 2x and divided by y minus tangent x times tangent 2x, right? And then you can also using the rules to do again, like a and b are both x, so that is a plus b equals to x plus x to 2x, and here equals to 2 tangent x and divided by 1 minus tangent x squared, okay? So just put into here and you're going to find that here equals to 3 tangent x and minus tangent x cubed divided by, here is for 1 minus 3 tangent x squared, okay? But then you can let t equals to tangent x and it can be just considered as 3t minus t cubed over 1 plus 3t squared. So in some problems, we are using these rules to help us to simplify the equations. And finally, after rearranging, you can find turns into a times t power 4 plus bt squared plus c equals to 0, or sometimes it's at squared plus bt plus c equals to 0, okay? So because that can help us to solve for t and then convert them into the quadratic forms, like you can just let t squared as maybe u, so that turns into the u squared, au squared plus bu plus c is a quadratic equation, right? So for these problems, for example, like here, like the first question shows that tan 3x equals to 3 cot x, and then can be written in the form here, okay? So first we set tan 3x, maybe let's just do this again, like for tangent 3x it equals to tangent x plus 2x, right? That can be written as tangent x times tangent 2x and divided by 1, here is plus, divided by 1 minus tangent x times tangent 2x, right? So for tangent 2x, we can set it equals to 2 tangent x minus 1, or divided by 1 minus tangent x squared. So this value can be considered then as tangent x plus 2 tangent x and divided by 1 minus tangent x squared, right? Here is for 1 minus tangent x times 2 tangent x divided by 1 minus tangent x squared, right? So for this problem, you can times tangent x on both on the numerator and denominator. So here it turns into, here is for tangent x minus tangent x cubed plus 2 tangent x. And here the denominator also times 1 minus tangent x squared that turns into tangent x minus tangent x cubed, and then minus 2 times tangent x squared. Okay, so if you let tangent x equals to t, so that this function will turn into 3t minus t cubed, and here it will be considered as here is for t squared, right? Here's for t squared. So here is for t minus 2t squared and a minus t cube, right? Minus t cube here. Okay. So we can just set for these equations, tangent x minus, oh, sorry. Here is for one, oh, sorry for that. Here is for 1 minus tangent x squared. Sorry for that. Here's for 1 minus tangent x squared. And then minus 2 times tangent x squared, right? Sorry for that. So here's for 1 minus t, 3t squared, right? Okay, so you have that. So we also knew that cosine x equals to 1 over tangent x, right? So that can be considered as 3t minus t cubed over 1 minus 3t squared equals to 3 over t, right? And then you can make a product on both sides. So that will turn into 3t squared minus t power 4 equals to 3 minus 9t squared, okay? And then we can just set here is t power 4, and then is for minus, here is for 3t squared and minus 9t squared, and then plus 3 equals 0. That is for t power 4 minus 12t squared plus 3 equals 0, right? And then we have, because t equals to tangent x, so tangent x power 4 minus 12 times tangent x squared, and then plus 3 equals to 0, right? That is our final answer here. Okay, so that is a proof for here these problems. So also if you want to calculate for tiny x exact value, you can just try to solve it, right? So for solving the problem is very similar, right? So you can just let u equals to tiny x squared. So we can just say here the function turns into u squared minus 12t, 12u plus 3 equals to 0, right? So we can just trying to calculate for this function that is for u squared minus 12u plus for 36 equals 33, right? Like I said, u equals to here is for minus, here is for 6 plus negative 33, right? So that is for t squared value. So we can just set like, because x is between 0 and 90 degree, so tiny x squared can also be considered as here. So the equation for tiny x squared can be sketched like this way, right? So 6 minus square root 33 is a positive value, and 6 plus square root 33 is equal to another value. So we have the two intercepts here. Also, we can just set here we have two solutions. So then you can use a calculator to calculate for square root, because here is tan x squared, right? So we can set this for x equals to tan inverse function for 6 minus square root 33, or tan inverse function for 6 plus square root 33, right? Okay, that is for this problem here. So I hope you can truly understand. Oh yeah, sorry. We have to also make a square root here. Okay. So you have to truly understanding for how to calculate these values here. Okay. So that's for this. So see you next time. Bye.